My name is Hunter Mackenthun, and I am a senior in aerospace, and I am the recovery team lead. So there's no really hard skills that are required for recovery. There's a whole bunch of skills that are helpful, like knowing SolidWorks. If you know how to sew, that would be great. Things like that, but really the most important thing is that you're willing to learn and put in the time to learn. When I started in recovery, I knew absolutely nothing about rockets or anything, but through 2 years of being on the team, I built my L2, learned how to sew, learned how to use SolidWorks and everything. So we start the year out by brainstorming. This year we worked on our reefing devices, a lot of brainstorming at the beginning of the year. Then last semester we also built and designed a subscale to figure out how big we were going to need our main to be. In previous years we've done wind tunnel testing, but this year we wanted to do an actual test with the rocket, so we built this parachute that you can see over here, and we flew it on my level 2 rocket and got the descent data, and from that we were able to figure out what size our full-scale parachute is going to be. This semester we actually go ahead and manufacture the full-size parachute and prepare it for the rocket. Here we have our reefing device that we've been working on this year. So inside of it you have our board, which is like all our altimeters and light sensors and everything that we're going to use to disreef the parachute. We also have a line cutter for cutting the line that chokes the parachute. And then we also have, of course, the power and the switch in there as well. This is made of PLA, it's just a prototype. The finished design is going to have an acrylic cover over the top, and it's going to be printed with ABS. And here, as I mentioned before, is our subscale parachute we built last semester. Uses ripstop nylon and everything. It's a 48-inch elliptical parachute. Here is a parachute from Rocket Man. What we did is we knew we wanted to test reefing before we were going to have our full-scale parachute completed. So we modified this Rocket Man parachute to be able to be reefed. You can see the reefing line running through it. So the skirt of the parachute is essentially restricted, and the reefing boxes are put in these pouches, and they have the line cutter, so at a certain altitude the line cutter goes off, cuts the line, and the parachute is allowed to fully open. So yeah, the biggest project, as probably mentioned, is the reefing devices. It's a project that we've been working on for a couple of years now. There's been a lot of iterations and a lot of trial and error, and this year what we wanted to do is we wanted to look at it, take a step back and say, all right, what's working, what's not working, how do we get this thing as simple as possible? The project essentially, the way the reefing works, is the rocket goes up and the parachute comes out, the full parachute comes out, but the circumference is shrunk, and so there's a quick descent rate, and then at a low altitude, the reefing line is cut and it allows the parachute to fully open so the rocket can come down nice and slowly.
That's propellant X, right?
Yeah. What altitude is supposed to disreef?
1,500.
1,500? That's...
There we go!
People should join recovery because out of all the sub-teams in cyclone rocketry, it's one of them that give you the best experience with hobby rocketry in general. You get to see everything that's involved with the recovery of the rocket, which is really half the battle. You get to work on the ejection system, the shock cord lengths, and the parachute sizing, deployment tests, all that really fun stuff. You get a lot of hands-on experience with just how rocketry works.